If you've already tried the warm-up and still have some questions, I wanted to go through these to show you how I would solve these. So first, they wanted you to factor here and find the x and y intercepts, the vertex, and another point and graph it. So when I factor this quadratic, this is going to factor into x minus 5 times x plus 1. Now, if we are looking for the x-intercepts, we just set y equal to 0. And when we do that, we can end up setting each one of our factors equal to 0. So we have x minus 5 equals 0 and x plus 1 equals 0. And we find that our x-intercepts are at 5 and at negative 1. And I'm going to write those x-intercepts here as coordinate pairs. So, sorry, that should be 5, comma 0, and negative 1, comma 0. So I'm going to plot those 2 points over here on my graph. And then we can look and see what is going to be in the middle of these two x-intercepts to find our axis of symmetry. And we see that these are 6 steps apart. And so we just need to half that, and we know that that's just 3 steps. And so that's here at x equals 2. So that's our axis of symmetry where x equals 2. And we know that that's actually going to be where our vertex resides. So if we want to find our vertex, we know that that is when x equals 2. And we can just plug that back in our equation to find the y value of the vertex. So we have 2 squared minus 4 times 2 minus 5. So we end up getting 4 minus 8 minus 5, or 4 minus 13, which gives us minus 9. So our vertex here is at 2, comma, negative 9. So I'll write that down here, 2, comma, negative 9, and let's go on and graph it, 2, comma, negative 9. Now I've got 3 points here for my parabola, but I want to try one more point. And really you just can kind of be strategic about the way you do this. I could, because I've got to find the y-intercept, I could go on and find that and just plug in 0 for x, and it's actually easier to plug that back into my original equation because I get 0 squared minus 4 times 0 minus 5. Both of those first terms are 0, so we just end up getting negative 5. So our y-intercept is going to be at 0, comma, negative 5. Well, this asks me for one other point, and I can use my axis of symmetry to just mirror that point, 0, comma, negative 5. Could be over here at 4, comma, negative 5. So that's my other point. I've got 5 points, and I can go and draw. Remember, this is just going to be a U shape. Make sure this looks like a U and not a V. A V is absolute value. So, but there we've got enough to go on and plot and draw our graph. So now let's look at this next example where we are looking at a different quadratic and they've asked us to complete the square. Now this has a leading coefficient other than 1, so my first step in completing the square is going to be to factor out that coefficient from just my x terms. So I factor out a negative 4 and I'm left with x squared minus 4x. And I'm going to leave a little bit of space to complete the square, and I still keep that negative 7. Now, if I want to complete the square, I'm going to take this 4 and I'm going to divide it by 2 and then square it. So 4 divided by 2 gives me 2, and 2 squared gives me 4. Now, I want you to be careful here and recognize that this 4, this green 4, is also being multiplied by that negative 4 outside the parentheses. So in essence, what I've done is I've subtracted 16 from my equation. So to balance, I've actually got to add 16. So now that I've balanced my equation, I can factor my trinomial. I still have negative 4. When I factor that trinomial, x squared minus 4x plus 4, that's going to factor into x minus 2 squared. And then we have minus 7 plus 16, which gives us plus 9. And so now I can easily pull my vertex, which is at 2, comma 9. And I'm going to go and graph that. We've got 2, comma 9 is my vertex up here. And I'm going to put this down in my information below. So now if I want to solve for my x-intercept, remember I just say y is 0. So if this right here is 0, I can actually move my 9 over. So I have negative 9 equals negative 4x minus 2 squared. And then I can divide both sides by negative 4, so I get 9 over 4 equals x minus 2 parentheses squared. And I've got to take the square root of both sides to solve for x. So I get plus or minus the square root of 9 over 4 equals x minus 2. Well, the square root of 9 over 4 is just 3 halves. And that's going to equal x minus 2. Now, I would split this up into two separate equations. You've got x minus 2 equals positive 3 halves, and x minus 2 equals negative 3 halves. It just helps to cut down on mistakes. So if I add 2 to both sides, 2 is the same thing as 4 over 2, and 4 over 2 plus 3 over 2 gives us 7 over 2. And again, if I add 2 or 4 over 2 to both sides, I end up getting 4 over 2 minus 3 over 2, which just gives me 1 half. So my x-intercepts here end up being 1 half, comma 0, and 7 halves, comma 0. And we could go and graph those. We've got 1 half, comma 0, and then we've got 7 halves, comma 0, which is basically like 3 1/2. Okay, if you want to draw your axis of symmetry, you can draw that. It'll just help you when you're mirroring your points when we get a little bit later. Now, if we're looking for our y-intercept, that's just when we set x equal to 0, and that's really easy just to go back to your main equation that you were originally given, because your first two terms are going to end up being 0, and you're just left with negative 7. So our y-intercept is going to be at 0, negative 7, and we can go in and plot that. Now, if we have the point 0, negative 7, we can use that axis of symmetry to mirror it on the other side. So that's going to end up being out here at 4, comma, negative 7 can be our additional point. And now I've got 5 points that I can connect. Again, I'm going to use that U shape. It's not going to be a pointy like a V. That should be a U shape to show that that's a parabola. And we've got all of the key information here.